for each class will vary in length based on how familiar you may or may not be with the material. So today's demo won't be as long as, say, when we get to very new material. But the point that we're trying to get across to all of our 107 students is you have to prepare for every class. You have to do daily work in the class. And we are going to be more of your facilitator and guide. We're not going to get up here and talk for 70 minutes and then expect that you've got it all in there and then you just reproduce it. We're going to give you some highlights, and we've created activities after that for you to work through either on your own. If you're more of the type of person who likes to work by yourself, that's okay. Or if you like working in a group, that's great, because we've got the classroom set up for you to work and communicate together. Okay, so there's going to be more responsibility on your part as a learner than maybe what you might be used to, say, if you're freshly out of high school, where you go to class 5 days a week and the teacher tells you everything you're supposed to know. Okay, so you need to read a book, whether it's online or whether you have someone has the soft covered book, or whether you got like this soft covered book, which I would recommend that you don't need the hardcover book, because that's the most expensive. If you like hardcover books, that's fine. You do have the option of just getting the e-textbook, which is exactly the same as this. It's just all online. But if you're the kind of person that likes to hold something and turn pages and mark up books, this would be your next option. But everybody has to have an access code. And the access code will get you into my math lab, which is where we're going to do all our homework. And I'm sure someone will mention that in a minute. Okay, so we have preview exercises and demo. Ashlyn, and is it still your turn or someone else at your table? Are there any numbers that we say, hey, everybody said, yep, that's fine, it's true, and we can move on? So anybody see anything that everybody agreed with? Number two, definitely everybody agreed with. I agree with you. Okay. Anything else everybody agreed with? 7, does everybody have a check besides 7? 7, yep, everybody has a check with 7. Good. Excuse me, let's do checks first. Okay, so let's put a check here. We'll put a check there and we'll come back to it if we need to. Okay. Anything else everybody agreed with? Number 8, everybody agreed with. Good. Anything else? 10. Everybody has a check for 10. Yes, everybody. The first one group didn't get to it, but let's say.
Well, we were just starting to do it.
Okay, I agree with 10. No, that's all right. And anything else? Okay. So what's going on with number 1? What's wrong with number 1? Yeah, the student that did this problem multiplied the exponents, and when you have multiplication with the same base, you add the exponents, right? So everybody has the correct answer there, x to the 7th. I agree with that. Then on 3, the right answer there that people wrote in was 31 square roots of 2. I agree with that, because when you add in math, no matter whether you're doing arithmetic or algebra, everything has to be like. Whether you add and subtract, they have to be like. And these are what we call like radicals. So you just add the number in front together. That's called the coefficient, 21 and 10. And then you say I have 31 of these things called square roots of 2. And 4 caught some of you, and then you kind of caught up. This is one of those typical mistakes people make. You confuse this problem with a problem that might look like this. Say, if you were squaring something that had all multiplication all the way across, or all division, and you raise something to a power, then that power will apply itself to each factor or the numerator and denominator. But once you have an adding and subtracting in there, it's a totally different ball game. Then you just write out what it means to square something, and then you use your distributive property twice, which some of you call FOIL. So we know our answer here is a lot bigger than what's there. It's, 16x to the 4th minus 8x squared plus 1. Okay. This one I'm going to come back to after, you can come back to after the teaching demo. I'll give you the correct answer. It's 3/4. I'm going to go over negative exponents and rational exponents in the teaching demo. Everyone seemed to do this okay. It's plus 12 because you're subtracting a -7, which means you add 7 to 5. And this one created some problems. We cannot cancel things that look like if there's adding and subtracting between them. You can only find factors of 1 to divide out without it affecting the value of this. So you have to factor the numerator, which looks like this. And again, I'm not going over this. This is the kind of prerequisite skill. This is P6 in your text, so go to P6 if you need some work with factoring. On page 72, they have a great summary of how to strategies for factoring. I would strongly urge you to copy that into your notes or onto your little cheat sheet, your index card, okay? And then you factor this, you get x plus 5, x minus 5, and now you see you could write this problem like this. Doesn't matter when you have multiplication. You see, so you could separate it like that, and this is just a nice big fat 1. So it doesn't change it. So this is your answer. That's reduced to lowest terms. The numerator has the factor x plus 1. The denominator has the factor x minus 5, and they're different. So that's your final result. And we're going after the same thing here. It cannot be reduced any further. That is true. Because what does this really look like? It really came from these two fractions. These are the two fractions we added together to get that fraction. So you can't go away and crossing off the x and calling that 5, okay? Because it's really 1 plus 5 over x. It's like a mixed number. Okay? So just throw in x equals 10 there, and you'll see what I'm getting after there in terms of mixed numbers. Okay, so I'm going to do my teaching demo now. It's going to be fast, and it, you know, this isn't the pace that new material will go at, but it's going to be fast. I'm going to clue you in on a little mnemonic that I use to remember the first two properties of exponents, and I'm going to go offline to do this, and you'll see why. In a particular one, we're using an exponent property, but it's not the exponent properties we just discussed. It's a combination of these two properties. When you have a product, that means you're multiplying, raised to a power. The power applies itself to each factor in the product. And sometimes you may have one of your factors is already a power that's being raised to another power. And here's where we multiply our exponents instead of adding them. Okay, so we got to use two properties here. So the first thing we're going to do is we're going to apply the 1/3 to each one of these factors. So we have 64 to the 1/3 times x to the 300 to the 1/3 times y to the 600 to the 1/3. Okay, so that's this property applied to 3 different factors. Now we have to simplify each one, and we have to remember, what does it mean to raise something to the 1/3 power? What does that mean, either in words or with another symbol? Yeah? The root, right? And if anybody grew up in a farm family or in this area, you have what we call root cellars, right? And that's where you put all your roots, like your potatoes and your beets and your carrots all go in the cellar. The roots go in the cellar. So this is the same thing as this, the cubed root of whatever your base is, in this case, x. So this says, what's the cubed root of 64? Does anybody know? 4. 4 times 4 times 4 is 64. Okay, so we've done that one. Now to do x raised to the 300 and the whole thing raised to the 1/3 power, we're going to use this property where we multiply our two powers. Well, when I multiply anything by 1/3, it's exactly the same as dividing it by 3, right? 300 times 1/3 is the same as 300 divided by 3. So I'm going to take 300 and divide it by 3, so I get x to the 100. And 600 divided by 3 is 200. So that's how I can simplify that expression using my exponent properties. Okay. Now 8 is what gave you all the problems on number 6, right? With your preview exercises. What do you do with a negative fractional exponent. It has to, it means placement. Yeah. And placement also, changing the placement of it is the same as taking its reciprocal. That's the way some people like to think about it. Some people say I flip it. But when do you flip it? Doesn't matter whether you do it at the beginning or the end or in the middle. And sometimes you want to say, just show me one way to do something and I'll always do it that way. Well, it doesn't work that way. There's like 3 or 4 different approaches to this. But what you have to realize is that every single one of these pieces of this rational exponent has a job to do. And as long as you do those 3 jobs, then you're okay. One of the jobs you have to do is you have to take the cubed root of that base. Because how can you write negative 2/3? You can write negative 2/3 like this, negative 2 times 1/3. That's negative 2/3. And we just saw a second ago that 1/3 means to take the cubed root. So the 3 in the denominator says take the cubed root of your base. The 2 says square your base, square it. And as Amber, is it Amber? As Amber said, that talks about the placement of where you put your base. And when it's, right now it's in the numerator, you'd put it in the denominator. If it were in the denominator, you'd put it in the numerator. It's like taking the reciprocal. It changes the position. It's a positional change. Okay. So which of these would you like to do first? Frankly, I don't want to apply the power to this number, get a really big number, and then try to find the root. It's much easier for my minimal brain here to say, how about if I take the cubed root of this thing first, and then I apply this? So that's what I tend to do. So the order that I tend to do it looks like this. If I literally wrote it out in all of its glory, it would be to do the cubed root first, and then I square it, and then I change its position or take the reciprocal. Those are the 3 steps. And if you multiply all 3 of these powers, you get negative 2/3. It does not matter whether I do this first, whether I flip it first, then square it, and then cubed root it. They're all the same. Or whether I square it first, then cube root it, and then flip it. It doesn't matter. What is important is that you do all 3 of them. I tend to do this first part right here. I take the cubed root of 8, I get a 2. Nice. I square it, and then I take the reciprocal. So I get 4 to the negative 1, which just says 4 is not happy being in the numerator. Put the 4 downstairs and call it a 4th. Okay, so that's 1/4. That's all that means, 8 to the negative 2/3. So now you can go back to number 6 at your leisure and try that. The answer to number 6 is 3/4, so hopefully you'll get that for the correct answer. Any questions on this? Hopefully it's familiar. Recently you've seen that. Why can't I subtract these? What's the reason? Yeah, the radicals aren't the same, right? They're not like, right? We want them, the only way we can add and subtract is if they look like. So can we make them look like? That's the question that you always have to ask yourself. So how do we make them look like? If each of these numbers has a number that divides into it, that's the same for each one. Do they have a common factor? Does 12 and 27 have a common factor? Do they share a factor? Which one? 3, right. So you can write 12 as 4 times 3. So you can write square root of 12 as square root of 4 times square root of 3. So that's where you start. You say 12 is going to be the square root of 4 times the square root of 3. Now you're subtracting. And then you write 27 so that one of the factors is square root of 3, so you can have a like radical. And what's its partner? What's the square root of 3's partner? Square root of 9, right. Okay. And then you finish it from there. This is 6 square roots of 3 minus 3 square roots of 3, which is 3 square roots of 3. Factor. You know the factoring technique that saves your life and you forget it all the time? When I teach, I'm serious, when I teach 096, I have my students put it on their palm, and if I could tattoo it, I would, but no, don't want it there for your whole life. Greatest common friend, greatest common factor. It's the first factoring technique you should always ask when you look at an expression and say, does it have a greatest common factor? And if you look at this, you say, yes, I see a 5 as a factor in each one of these terms and an x. So the GCF here is 5x. So when you factor, you're rewriting that subtraction problem as multiplication. Since you have two terms, you have to have two things on the inside of those parentheses. If you divide 5x cubed by 5x, you'd be left with x squared, so that's what goes inside here. And if you divide 45x by 5x, you'd have a 9. Unfortunately, you're not done because another factoring technique comes into play with x squared minus 9. It's the difference of two perfect squares, and the factors look almost identical, x plus 3x minus 3. Right. So this is all in section P6. Okay, to reduce this, what do we have to do after our, the problem we did, number 11? What do we have to do to reduce that? Factor, 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 factor. Can you guys help me factor the numerator? Anybody factor that for me? Of the denominator? Any piece of it? Yeah, can you factor the top, Amber? What is it? Okay, how about someone else for the denominator? Anybody help me with the denominator? Okay, does everybody agree with that? Does that seem to work? Okay. Do we see any common factors, top and bottom? X minus 2, there's our foo-foo. Fancy form of 1. Ian uses that as well, if you've had Ian. So it's x plus 5 over x plus 4. You don't need the parentheses. I always put the parentheses in for you to see them as two very different things, and you don't have the temptation of canceling those x's, okay? The final one takes a little work. To add, they have to look like. So they have to have the same denominator. So you have to find a new denominator that has x plus 2 and x minus 2 as factors. That's called the multiple, the common multiple. So since both x plus 2 and x minus 2 are prime, this is the kind of problem you like because this would be the multiple of the two of them. You just multiply them together. So this is what you call your lowest common denominator, which is the multiple of those two. So when you rewrite this, they're now going to have a new denominator. And that new denominator will be the same for both, so you can then add them. And now the big trick is, how do you change this first fraction so it looks like this? And that's where you use the idea that now you can multiply any fraction by 1 without changing it. So you want to change this to an equivalent fraction that has x plus 2 times x minus 2 in the denominator. So you do a little comparison test. You say, hey, this one has x plus 2. This one has 2 factors. So this one's missing something. It's missing x minus 2. So you can multiply the denominator by x minus 2. But whatever you do to the denominator, you must do to the numerator, because there's your fancy form of 1. So it looks different, but it really has the same value. It's the same exact fraction. So this is 3x times x minus 2. So you do 3x times x minus 2. So this fraction changes to this one. Now you have to change this fraction, x over x minus 2, to a new equivalent fraction that has x plus 2, x minus 2 on the bottom. And to do that, you say, you do another comparison test. You say, what does this fraction have that this one doesn't have? And what's your answer? X plus 2, right. So you multiply the denominator by x plus 2, and you must also do the same in the numerator to keep this fraction equivalent. So you have x times x plus 2. So now we have x times x plus 2. And now the sad part is students do all this work, and you know what they do? They then go back and reduce it. So often what I have students do is instead of actually writing in the denominator here, I just have you be a little lazy. The only time I encourage laziness, and I just say write the letters LCD there so that you're not tempted to cancel anything or reduce it before you actually do your addition. So now you have one big fraction bar. You're going to squish them together now because they have the same denominator. And you just figure out what each numerator can be represented by. So this is 3x squared minus 6x plus x squared plus 2x. And now you simplify your numerator. Now throw in your denominator. Now your only question is, can I reduce this fraction? And the only way you're going to be able to reduce it is if you have an x plus 2 as a factor in the top or an x minus 2. So you look at your numerator and you say, well, I can factor it. I can pull out a 4x, but what's left is x plus 1. So it can't be reduced. So you can either leave it like this if you want. You could factor it and then circle it, but that's all you can do at this point. Okay, yep. You're right, it is a negative 4x because Linda made a mistake. Thank you. It's minus 4x. Thank you. Yep. Still can't reduce it though. Okay. So, I mean, if you did all that and it was worth like 6 points and you made a little mistake like that, it'd be like a point. You know, the main thing is doing all your work so I can see your thought process. We all make mistakes, right? Okay. So, what do you have left to do now for Friday? Well, kind of get your life together with all your classes and get back. This class activity we didn't have enough time for. This will be something that you can do on your own. Notice all the answers are at the top of the next page. So if there's certain pieces of this that you think you need more practice with, try it and then check out the answer. Some of it you look at, you say, I know how to do that. I don't have to bother. That's okay as well. This is for you at this point. We didn't get to it today. All right, your homework's here with the due dates, okay? And so before you come in Friday, you're going to look at section P1 in the textbook, do a quick review, look over these preview exercises at the beginning of class 2. You don't have to do them, but be prepared to do them when you come to class. Okay, I'm not expecting you to like learn all of the preview material. I just want you to get a sense of what we're doing, and they'll always, every class will start with preview exercises, okay? All right, I'll see you Friday. Have a great couple of days. Hopefully we'll see each other Friday. I hear another storm is brewing. So let me shut this off.